We are revising grade 12 and GCE paper 1. And the questions that we have here that came in the past papers. The first question is the use of gradients of perpendicular lines. The question states, given that the lines 3y equals x plus 6 and y equals kx plus 12 are perpendicular, find the value of k. For us to find the value of k, we're going to use what we call the gradient property of perpendicular lines. So what does this say? M1, which is the gradient for the first line, multiplied by the gradient for the other line, which is perpendicular to the first line, is always equal to -1. We are given 3y is equal to x plus 6, and on this other side, we are given y is equal to kx plus 12. We are told these two lines are perpendicular. Now, when you look at this line here, it is written in standard form, and therefore we can say the m2 here is equal to k, because that's a gradient. But then when you look at this one, it's not written in standard form. So we need to write this one in standard form. So how do we do that? So we say 3y is equal to x plus 6. Then we divide both sides by 3, or throughout by 3. And so we get y is equal to 1 over 3x plus 2. It's also now in standard form. Then we now say m1 is equal to 1 over 3, because that's a gradient. So using these two gradients, we are saying m1 multiplied by m2 is equal to -1. We replace them, so it's 1 over 3 multiplied by k is equal to -1. Since there is multiplication here, to get rid of this denominator 3, we multiply throughout by 3. So we have 3 multiplied by 1 over 3 times k is equal to 3 multiplied by -1. This will divide with that, and so we have 1 times k, which is k, and this is equal to 1 times -1 gives us -3. And so this is the value for k. Our next question is on the magnitude of a vector. We are told that A is the point -2, and B is a point 1, 5. Find the magnitude of vector AB. Now, let us first of all identify these issues. So we have A as our point, -2, 1. Since this is the first point, we're going to say -2 represents x1 and 1 represents y1. We also have B, which is the point 1, 5. And so here we are saying this is x2 and this is y2. But of course, the numbering of these value points doesn't really matter which one you start with. It will still give you the same. Okay? Now, we know that the magnitude of a vector is given by the distance formula, which is x2 minus x1 squared plus y2 minus y1 squared. So when we substitute the values, we find that this value here, the square root of this becomes, or this replaced is 1 minus -2, then everything squared, plus this other one is 5 minus 1, everything squared. So when we do the simplification, this one is 3 squared plus this one is 4 squared, which gives us that is 25. because this is 9, this is 16 added together. And so you find that the square root of 25 is 5. This is the answer for the magnitude of vector AB. The next one that we have is on indices. Given that 8 to the power x minus 1 is equal to 16, find the value of x. Here, we are using the knowledge of indices. So what knowledge do we know? Let us write the question. We have 8 to the power x minus 1 is equal to 16. Now, these two numbers, if you look at them and consider them, you realize that 8 can actually be written as 2 to the power 3 in index form, and 16 can be written as 2 to the power 4. So, where there is 8, we are going to replace with 2 to the power 3, and there, where there is 16, we are going to replace with 2 to the power 4. So we have here, instead of having 8, we're going to have 2 to the power 3, then everything to the power x minus 1, which is equal to 2 to the power 4. Now, here you notice that when you have such a situation here, it means you're multiplying. So we have 2 to the power 3 times the x is 3x minus 3, which is equal to the power 4. We know the indices that when you have the same base, you simply equate the powers. So we have 3x minus 3 is equal to 4. So solving for x in this equation, we have 3x is equal to 4 plus 3, where 3x is equal to 7, and then we divide 3x divided by 3 is equal to 7 divided by 3. We divide here, we get x is equal to 7 over 3, and that is our answer. Now, let us try to see whether our answer is correct. So how do we do that? We're going to do it here. Let me use a different color. Let me use the color red to demonstrate how this is done. So we are told that 8 to the power x minus 1 is equal to 16. That's the situation. So we are going only to concentrate on this side and see whether we're going to prove this side. So we have 8 to the power 7 over 3 minus 1. Now this can also be written as, well, we can write 1 as 1 over 1. So we have 7 over 3 minus 1 over 1. And here we have 8. Then we have a common denominator. 3 times 1 is 3. 3 into 3 is 1. 1 times 7 is 7. Then minus 1 into 3 is 3. 3 times 1 it is 3. So when we subtract those to simplify, we have 4 over 3. But then what does this mean in indices? We can actually find this. We're saying the cube root of 8, then raised to the power 4. So we can now say we are talking about the cube root of 8 and then raised to the power 4. So what is the cube root of 8? It is 2, which is raised to the power 4. And so when 2 is raised to the power 4, the answer is 16. So you can see that we have come up with the same answer that we are talking about. And so this is our value